things. You've already studied about volcanoes and earthquakes. I want to ask you a few questions. If you need to look back in your book, you may. First question. Who can tell me where volcanoes usually occur? Where do volcanoes usually occur? Patrick?
Near the plate.
Good. Near what particular parts of plates? The middle of plates? The boundaries of plates. The boundaries between plates. Correct. Who can tell me the name of the molten rock that's inside a volcano before it erupts? What's that called? Magma. Right. Who can tell me what they mean when they say there's a ring of fire? What does that mean? What's the ring of fire? Chrissy? Exactly. The string of volcanoes in the Pacific Ocean can make sort of a circle in the formation. Moving to earthquakes. Who can tell me what we call the cracks in the crust where earthquakes usually occur? Jason? Faults. Who can tell me some of the ways the ground can move? You can use your hands to demonstrate if you need to. How can the ground move in an earthquake? Robin? Okay, it can slip up, down, side, and side. Exactly. Remember how we use the blocks to demonstrate. And last question, what is the machine that they use to measure how strong an earthquake is? Seismograph. Right, seismograph. Yeah, they can also move diagonally. Today we're going to change our study to mountain formation. We're going to study how mountains are formed. And you'll notice that there's some similarities in where mountains form and where volcanoes occur and where earthquakes occur. I'd like for you to take a minute and look at the map at the front. I want to name some mountain ranges, and I'm going to ask some volunteers to go up to the map and point out those mountain ranges. Now, before we start, what color on that map stands for the highest mountain ranges? What's the highest elevation? Antonio? It's kind of hard for you to see the keys on back there. Bobby? The brown. The brown is the highest. And then if you see something that's in orange or even yellow, that's also a pretty high elevation. All right? First mountain range, the Himalayas. Who can find the Himalayas on the map? You need help. Jamaica, you want to try? You're looking sort of in the right place. You need to move over to Asia, below China, and above India. The big brown area. There you go. Those are the Himalayan mountain ranges, okay? Those are the highest mountains in the world. That's why you see so much brown there. Mount Everest is located there, which is the highest mountain. Second range I want you to look for, this will also be colored brown because it's a high range. The Andes. Christine. Right. The brown right there along the coast of South America. This third range you're familiar with, but it doesn't show up as well because it's not real brown, just a little bit of it's brown. The Rocky Mountains. Where are our Rocky Mountains? Jason, go show me. There you go, western part of the United States. And the last one I'd like for you to look for is the Alps. You've been studying Europe and social studies. Where are the Alps? Ken. That's going to be Africa. You need to go to Europe. Try over here. Some yellow, orange here. Okay, that's another range. The Alps are going to be right in here. Okay, now Switzerland and Austria. All right. Why are some of the mountains like the Alps colored differently from mountains like the Himalayas? Bobby? They aren't as high, exactly. But were mountains that you see on this map right now always there and always at the same height they're at right now? Were they always there, Patrick? No. In fact, they found seashell fossils at the tops of lots of mountains. What would that indicate? Sharon? that the mountains were at one time underwater, at least a lot of them were. And today we're going to try to figure out exactly how those mountains were formed. On this island, I don't know the name of the range, but it's New Zealand. It's a pretty high range in New Zealand. Okay? What I want you to do is open your notebooks to a clean sheet. And we're going to do this in 2 stages. I'd like for you to label your page types of mountains, and then I'd like for you to copy the 3 definitions. Now you'll notice that at the top, under types of mountains, I've listed 3 kinds. I want you right now just to copy the definitions that come under the word match. And leave a space so that you'll be able to go back and fill in which belongs where. Be sure to leave enough space that as we discuss these different kinds of mountains, you can fill in which goes with which. As you finish up, be thinking about which word you think matches which definition, but please don't write it down. All right, you finished now? And what does the first definition say, Patrick? And the second definition, Julie? And the third, Ernest? All right, as we talked about 3 kinds of mountains, as you hear a definition that matches, fill in the word that matches the definition. All right? The first kind of mountain I want to talk about is folded mountains. And in order to show you how folded mountains form, I want to do a little demonstration. Let me move this over again so those on the right can see. I'd like you to look at the stool to my left. Now obviously the crust of the earth is not exactly like my old rundown bath towels, but I want you to pretend that this represents a plate and this represents another plate. And when the crust of the plates come together, we get folded mountains. Watch what happens. Very simple. You can try it at home. As the plates move very slowly, the crust starts to buckle, and lo and behold, you have mountains. Folded mountains are formed when crusts of plates collide. Now the plates may be plates that carry continents, or they may be plates, one plate may carry a continent and another may carry an ocean. But if the plates come together like that, you'll notice that the crust buckles up and it forms mountains. We call them folded mountains. Let me show you another example. Now this one I practiced at home last night with my Play-Doh, but I might need a little intervention to make it work exactly right because the clay doesn't buckle quite as well as the towels. Pretend that this is a plate carrying a continent and this is a plate carrying another continent. Now they're moving very slowly. We're speeding up time by millions of years because they move so slowly. But as the plates collide, you'll notice that the surfaces tend to rise. I'm going to define intervention here. And you end up with a mountain range. That's how the Himalaya mountain formed. That's also how the Andes mountains formed, by collision of plates. It's also how several other mountain ranges in the world formed. When plates collided, the crust pushed up and formed mountain ranges. Okay? Look in your books at page 351. 251, excuse me, 251. On page 251, you should see some examples of plates drawn. Right. Looking at that map, find the plate that would include India. Yeah, find the plate that would include India. India would be in the southern part of Asia. India is on the very far right-hand side of your map, and it's that little triangle that's sort of sticking down in green off of Asia. You should notice that there's a black boundary line that sort of cuts across India right around here. Okay? That boundary line, you'll notice, coincides with the Himalayan mountains if you look at the map. And what happened is that the plate that carries India is moving into and under the plate that's carrying this upper part of Asia. And it's still doing it today. That means these Himalayan mountains, which are already the highest, are going to keep getting higher. Why? Why will they keep getting higher? Christina? Because the plates continue to push together. We say the plate carrying India is colliding with the plate carrying Asia. And these mountains will keep on getting higher. All right? Goes along with. Okay? The plate boundary line goes right along with the Himalayan mountain range. All right? What do we call the mountains that are formed when plates collide? Anyone? What kinds of mountains are we discussing? Folded mountains. Folded. You can think of it by the towels moving together, and you see folds. They're folded mountains. All right? A second kind of mountain range is called fault block mountains. And these I want to illustrate to you using some blocks. Fault block mountains are formed in a way very similar to earthquakes. Okay? You remember when we studied earthquakes, we said that you had the crust of the earth, represented by these two blocks. If there was a crack in the earth, and when along the crack you get some slippage, you have an earthquake. Now sometimes you get some crust that has two cracks in it, like so. All right? And when you have two cracks and a lot of pressure, sometimes two of the blocks of earth will slip down, and one block of earth will move up, and lo and behold, you have a mountain called a fault block mountain. The crust of the earth started like so. Everything was flat. There were cracks on two sides. There was pressure. And then two sides slipped down, one side slipped up, and what did you end up with, Jamaica? A fault block mountain. You can remember that because what do we call cracks in the earth, Jason? Faults. And so if this is a fault block mountain, the faults cause the mountain to form. Okay? Fault block mountain. In some books they'll call it a block fault mountain, but it means exactly the same thing. Your book calls it a fault block mountain. By now you should have two definitions filled in. Which definition should you have already matched? Antonio. Okay, read it for me. Okay, what goes with form along cracks in the crust? Fault block mountains. What goes with form when plates collide? Folded mountains. An example of a fault block mountain, if you've ever been to Wyoming, they have a range called the Tetons, T-E-T-O-N, or the Grand Tetons. And the Teton mountain range is formed from fault blocking. Okay? Fault block mountains make the Grand Tetons. Any questions so far? All right, let's move to the third type, which will be dome mountains. Dome mountains don't usually form in ranges. Okay? They usually form separately. Now I want you to pretend the crust has changed its color, that this is just a big block of crust, or a big block of earth. And I want you to pretend that this red stuff is magma. Okay, just like we studied about volcanoes. Sometimes the magma will push up on the crust, just like it does when it forms a volcano. All right? It'll push up, and it'll push up, and it'll push up, but it'll never come through. Okay? And so you end up with a mountain that looks sort of like this. Sort of like the top of an ice cream cone. It's not real high. Okay? It's not a range. It's just a rounded mountain. We call it a dome mountain. Dome-shaped meaning the wide, round top. The magma is down here. The crust is up here. But the magma cools before it ever comes through. So it's not a volcano. It's a dome mountain. Okay? How many of you have been to Georgia? How many have seen Stone Mountain in Georgia? Anybody? All right, Stone Mountain is the perfect example of a dome mountain. All right? It's large, it's rounded, and it has cooled magma inside it, just like this. Right, look at page 256. And you'll see a picture of a dome mountain, Stone Mountain. You'll notice that it looks awfully flat on top. What might have caused that mountain to look so flat on top? What causes mountains to flatten out? Age. It's an old mountain. Okay? By now you should be able to fill in the third definition. Who can read me the third definition and tell me the kind of mountain that it refers to? Michael? And what do we call that? A dome mountain. 3 different ways that mountains are formed. Now there's another way that you've already learned about when we studied volcanoes. Sometimes mountains form from volcanoes. Okay? But the 3 main kinds I want you to be familiar with today are what? Who can give me the names? Renee? Fault block, folded, and dome. One more thing. Your book talks to you a little bit about erosion. The mountains that you see today, 1,000 years from now, won't look like they look now. Why, David? Okay. The water and the ice and the wind is going to cause those mountains to wear down. And like we saw in the movie a couple of days ago, eventually, I'm talking a long, long time from now, not while we're alive, what might happen to some of those mountains? besides just wearing away on top so they're going. Yeah, they become totally flat again. You won't see that in your lifetime, and neither will your children or your grandchildren. But it happens because erosion is constantly taking place. How can you tell whether a mountain is a new mountain or an old mountain based on erosion? Listen again. How can you tell whether a mountain is new or whether it's old based on the effects of erosion? Casey?
Old mountains are flat on top, they don't have smooth points and peaks.
Right. The mountains with all the peaks, like the Alps, like the Himalayas, those are the young mountains. They're the babies, okay? They haven't been around that long. They're still real pointed and peaky. But then mountains like the Appalachians, if you've been up to Grandfather Mountain, or if you've been to Boone or Asheville, those mountains are real old mountains. And you don't see them as tall and peaky as, say, the Rocky Mountains. Instead, they're rounded out and flat. Look at page 257 in your books. They give you a picture of the Rocky Mountains and they give you a picture of the Appalachian Mountains. Which of the two is younger? Which is the younger range? Tim? The Rocky Mountains. How can you tell? Right. They've got the peaks. The Appalachians are old mountains. You can remember Grandfather Mountain. That's part of an old mountain range. Okay? Any questions? All right. Close your books. Close your notes. I'd like to give you the definitions this time and see if you can match them without looking at any of your notes in your book. Who can tell me the kinds of mountains that are formed when plates collide? What kinds of mountains are formed when plates collide? Ernest. Folded mountains. Good. What kinds of mountains are formed if magma pushes up through the Earth's crust but doesn't break through? Robert. Dome mountains. What kinds of mountains are formed if you have some cracks in the Earth's crust and some slippage? What kinds of mountains are going to form, Casey? Fault block mountains. Good. I'm going to give you a worksheet. It's vocabulary. It includes not only what we studied about mountains, but also what we studied about earthquakes and volcanoes. You may use your notes and books to complete it. If you finish the assignment before it's time to go to art, which is highly unlikely, but if you do, you'll notice that you have a science assignment. It's the questions on page 383 involving mountain building. Worksheet in class. This is something I'd like to collect before the day is up. Your notes on vocabulary will help you with this, considering your reference. You'll notice when you finish, the words that are, the letters that are boxed in will form a special phrase if you do it correctly. All right, listen up for just a minute. I think you've done a real good job of listening and working. I appreciate that. It's time to get ready for art, so we will continue with this when we come back from art. Would you please put these in your books, the worksheets finished or not? I'm waiting until after art to collect them. And you may leave your books on your desk if you would like. Leave the worksheets in your books. Come back through after art. And if you're in row 1, once you've got your worksheets up, please line up.